Hello everyone, my name is RakshaPatel and today I'll be presenting my final project for the course Discovery and Learning with Big Data. In this presentation, I will first discuss how machine learning can be applied in a business setting in real world. Then I will explain the data pre-processing steps followed by a supervised learning model using linear regression. In the next video, I will continue with classification models, uh, clustering and model comparison. So let's begin with part 1 where we will see how machine learning can be strategically applied in a real world business. So I selected Sprouts Farmers Market. Sprouts Farmers Market is a publicly traded grocery store chain based in the US. This company offers affordable natural and organic foods to health conscious consumers. It has more than 450 stores in various parts of America. The company competes in the highly competitive retail grocery industry with other companies including Whole Food Market, Trader Joe's, and Kroger. Uh, Sprouts Farmers Market has about 35,000 employees. So now that we understand the company background, let's see why this company needs machine learning. There are several important reasons. First, consumer expectations are increasing day by day, and customers are now expecting personalized product recommendations, targeted offers, and better overall shopping experiences. Second, the company handles large amount of customers and transaction data which cannot be efficiently analyzed without machine learning techniques. Third, company faces inventory challenges especially because it deals with perishable goods such as fruits, vegetables and dairy products. So overstocking leads to waste while understocking result in lost sales. So company need to figure it out, and AI and machine learning can help to better using their resources. Finally, company operates in a highly competitive environment where other retailers are already using advanced technologies to improve pricing, logistic, and customer engagement. So, need for machine learning technology is strong. So, based on these needs, let's see how machine learning can be applied in this business. So machine learning can be used in several important ways. First, it can provide personalized product recommendations by analyzing customer purchase history and preferences. This allows the company to suggest relevant products and improve customer satisfaction and loyalty. For instance, if a customer regularly buys organic vegetables, the system can recommend related organic items or discounts. Second, it can be used for demand forecasting. By analyzing past sales data, seasonal trends, and consumer behavior, the company can predict future demand for different products. This is especially useful for perishable goods because it helps reduce waste while ensuring availability. Third, machine learning can support price optimization. The company can adjust product prices dynamically based on demand, competition, and product availability. For example, if demand is high, prices may increase slightly. If demand is low, company can offer discounts. This helps maximize profits while staying competitive in the market. And finally, machine learning can improve supply chain by optimizing logistics, inventory management, and product distribution, leading to better operational efficiency. Now, let's move to the technologies and resources required to implement this strategy. The company requires cloud infrastructure such as AWS or Google Cloud to store and process large volumes of data. It also needs machine learning tools such as Python and scikit-learn to build predictive models. Data management systems are also necessary to organize and analyze customers and sales data. Company also needs skilled professionals such as data scientists, analysts, and experts to develop and maintain this all systems. And the organization must also train existing employees so that they can understand and work with machine learning system. This is important because adopting new technology requires both technical and organizational readiness. Furthermore, data security and privacy measures are essential to protect customer information and consumer compliance with regulations. Finally, it is recommended that companies starts with small pilot projects before implementing machine learning solution across all stores. So this is how technology can help for Sprouts Farmers Market to stay in competition. So this completes part 1. Now let's move to part 2 where we will see the data pre-processing steps. The dataset used in this part is animal shelter dataset, which contains approximately 95,300 records and 10 attributes. Before pre-processing, let's first understand the key challenge in this dataset. The main issue was that the age of animals was stored as text values such as 2 years or 5 months, which cannot be directly used in machine learning models, right? So we need to clean the data set for better model results. So to address this issue, several pre-processing steps were performed. As you can see here in the image, like there are a lot of steps eh, to pre-process the data. First, irrelevant attributes such as animal ID, date, time, month, year, and date of birth were removed because they do not contribute to prediction. Like also removing irrelevant attributes improves model efficiency because unnecessary data can confuse the model and reduce accuracy. Uh, in second step, each upon outcome like attributes were converted into numeric format by transforming all values into months. For example, 2 years was converted into 24 months. Then converting age into numeric format is very important because machine learning models cannot process text values, right? The next step is missing values were handled by removing records that contained incomplete data. Handled missing values ensure that model does not produce incorrect or biased result. That is why it is important to remove that. And fourth step is invalid values such as zero age were removed because they are not meaningful for prediction, and removing invalid values like zero age improves data quality as well and leads to better prediction. Finally, the clean data set was saved as CSV or Excel file. After pre-processing the data, we can now move to building machine learning models. So let's begin with part 3, linear regression. The dataset used here is Avalon dataset, which contains around 4,000 records with multiple physical measurement features. First, let's understand the goal of this model. The objective is to predict the age of abalone based on their physical characteristics. Before building the model, pre-processing steps were required. So the categorical variable X was converted into dummy variables and a new variable called age was created using formula age equals to rings plus 1.5. So all variables were also verified to ensure they were in numeric format. So now let's look at the model itself. The model is a supervised learning model and the algorithm used here is linear regression. So the data set was divided into 67% training data and 33% testing data. And linear regression was selected because of many reasons. So here the goal is to predict a numeric output variable, and in this approach model first predicts the number of rings and then age is calculated as predicted rings plus 1.5. This model is suitable for linear regression, especially because target variable is continuous, and it is also very easy to interpret as it provides useful outputs such as coefficient, intercept, R square value, and predictions, etc. So model provides coefficient for each variable, which helps us understand how each features affect the predicted age. For example, variables like diameter, height, and shell weight have positive coefficients, meaning they increase the predicted age. So additionally, during EDA, it was observed that there are mostly positive relations between abalone size and weight variables and the number of rings. So based on that, linear regression was considered as appropriate model choice. That is why linear regression model is selected here. Now let's look at the result and evaluation of this model. Model achieved an R-squared value of 0.5352, which indicates moderate performance. This means that about 53% of the variation in the abalone age is explained by the model. This model has moderate performance, which means it is useful, but it's not perfect. This is expected because abalone age may depend on other biological or environmental factors that are not included in the dataset. So when tested with new records, predicted age were 11.5 years and 9.7 years for both the records respectively. So this result shows that larger abalone tend to have a higher predicted age while smaller ones tend to have lower predicted age. So the cross validation mean squared error was around 4.94, which indicates that the model has a moderate prediction error. This means that while the model prediction are close to actual values, there is still some variation. So these are the results, and as I said, the main insight here is larger the abalones, higher the predicted age. So this completes part 1, part 2 and part 3 of my project. In the next video, I will continue with logistic regression, k-means clustering and model comparison, mainly comparison between two regression models and two classification models, and then will provide final conclusion. And yeah, thank you. I'll continue in the next video. See you in the next video. Thank you for listening to me.